In this lesson on quadratic equations, we are going to talk about at the introduction level that if you are given any polynomial such as this, in which we have certain number of terms, how do you identify whether that specific polynomial is quadratic or not? Okay. So if I look at this expression, it has three terms, ax square plus bx plus c. It is the highest power, the exponent in this polynomial, that determines whether any specific polynomial is quadratic or not. And the moment you see the highest power is 2, as you see here, that itself is an indication that it is a quadratic equation, right? And then you see that in this specific term, ax square, we have a value a. This value is called the coefficient, and we have a necessary condition as stated here that a cannot be equal to 0. Why? Because the moment you set a equal to 0, that means this whole term will disappear, right? And it won't be quadratic anymore. Hence, this specific condition of a not equal to 0 is a mandatory condition for any quadratic equation. It could be any positive or negative number except 0, all right? And then we look at the second term, bx, where b is any constant and x is, of course, a variable, right? And the last term is c, where c is just a constant. And you also notice that we have set this expression equal to 0, because you see that without this part in which we are setting up this expression equal to 0, without this part, it is only an expression. It is only that when you equate that expression to something which is 0 in this case, only then it becomes an equation, right? So we learned about few things. We said that any polynomial becomes a quadratic only when the highest power in that polynomial is of degree 2, right? And if that is the case, we need to make sure that the coefficient of that variable is not equal to 0, which is a condition right here. And then we have some more terms. So this is called a quadratic equation. Okay, now I'm going to give you two examples in which we will evaluate whether a given expression is quadratic equation or not. Okay, so let's go take a look at those examples. So the given task is that we have to check whether the following expressions are quadratic equations or not. Okay, so the very first one is x minus 1 whole square plus 2 is equal to 3x minus 5. Well, at first glance, it looks like a quadratic equation because we have a variable x here and then we have a power of 2, which is outside this parenthesis, right? So it does appear like a quadratic equation, but we need to be very sure about it. So let's solve the example 1 and see what it reduces down to. So my example 1 is x minus 1 whole square plus 2 is equal to 3x minus 5. Okay, so when I expand on the left hand side, I see that x minus 1 whole square can be stated to be x square plus 1 minus 2x. I am simply utilizing a standard identity, which is a minus b whole square is equal to a square plus b square minus 2ab. Okay, and that's exactly what I've done here. Okay, then the rest of the parts in this expression are 2 comes as it is, and this is equal to 3x minus 5. Now, let's do this. Let's take this 3x and move it from the right hand side to the left hand side of the expression, and take this 5 and move it to the left hand side as well. Okay, so when I do this, I can simply rewrite my first part to be x square plus 1 minus 2x, and the term 3x, as we move from right hand side to the left hand side, it will change its sign value. So it will become negative 3x, right? Then we write plus 2 as it is, and then we move this term negative 5 to the left hand side. So it will become plus 5, right? Now let's combine the like terms together and simplify this expression. By the way, this expression on the right hand side can be set to be equal to 0. So once you simplify all of this, you will find that the first term is x squared. Let's write it down. The x part, which is negative 2x and negative 3x, it becomes negative 5x, correct? And then we have three constants, plus 1, plus 2, and plus 5, and together all of them will be equal to 8, and this whole thing is equal to 0. Now, what do you notice? That you have an expression here. The highest power of this is 2, and the coefficient of x square is not equal to 0. So we will say that this is indeed a quadratic equation. And yes, it is. answer to the question first is yes, it is a quadratic equation. So just like that, let us evaluate our question number 2, in which the expression given to us is x times x minus 2 minus 4 is equal to x plus 2 times x plus 10. Okay. Now at first glance, when I look at this problem, I see that there is an x term here and there is a power of 2, and I also see there is a power of 2. So it does look like a quadratic equation. But to be sure, we want to make sure that we expand and simplify before we conclude our answer. All right. So when I expand and simplify, my left hand side will be x times x minus 2. When I open up these parentheses, I get x squared minus 2x minus 4. This is equal to, when I expand the right hand side, I will see that x will be multiplied with x and 10. So it will be x squared plus 10x. And then the term 2 will also be multiplied with x plus 10. So that will be 2x plus 20. Now let's do this. Let's transpose all of these figures from the right hand side and bring them to the left hand side. Okay, and then write the like terms together. So first I have x squared. So I will write x squared, and then you have this value of x squared here on the right hand side. So the moment you bring it to the left hand side, it will be minus x squared. Then you go to the next part, which is negative 2x. I will write as it is, negative 2x. And from the right hand side, I will get plus 10x. When you bring it to the left hand side, it will become negative 10x. And this plus 2x will also become negative 2x. Then you have negative 4 here, right? This will be as it is. And the term on the right hand side is plus 20. And when it comes to the left hand side, it becomes minus 20. So now let us combine all the similar terms together. So first you see x squared minus x squared, it becomes 0, right? These three terms, negative 2x, negative 10x, and negative 2x again, together, all of them will be negative 14x, correct? And these two terms will be negative 24. And this is equal to 0. Or in other words, you have a linear equation, 14x minus 24 is equal to 0. It is not quadratic anymore. See, that is why I was telling that we always need to evaluate after expanding all the terms and gathering the like terms together. And that is exactly what we did here. That apparently this expression, it did look like a quadratic without expanding and solving. But once we simplified, we realized that it is not a quadratic equation, right? So the answer to our problem number 2 is that it is not a quadratic equation, okay? So this is how you evaluate whether any given polynomial, if that is a quadratic equation or not. Okay, so this is where we pause for this introduction level lesson. In the next 3 tutorials, you will learn about how do you find the zeros or the solutions of quadratic equations.